Hello, my name is Keith Capellaro from K-Dawg Weather, and today we're going to be talking about understanding weather fronts, key drivers of atmospheric changes. The agenda today overview is fundamentals of weather fronts, types of weather fronts, weather changes associated with fronts, forecasting and identifying fronts. Fundamental of weather fronts. Definition and characteristics of weather fronts. The definition of weather fronts. Weather fronts are boundaries separating air masses with different temperature and humidity levels causing weather changes. Indicators of fronts. Shifts in temperature, wind direction, and atmospheric pressure helps identify presence of weather fronts. Role in weather development. Weather fronts serve as key zones where significant weather phenomena develop and evolve globally. As you can see, the different types of pressures, of fronts. How fronts form in the atmosphere. Air mass convergence. Fronts form where air mass with different temperature and moisture levels meet, creating zones of atmospheric stability. Density differences. Warmer, lighter air rises over cooler air, denser air due to differences in density, driving vertical air movement. Weather formation. The uplift causes cloud formation and precipitation influencing weather patterns and atmospheric circulation. Many types of weather fronts. There are many types of weather fronts of a cold front, which is cold fronts involve advancing cold air pushing out warmer air, often causing storms and temperature drops. Warm fronts occur when warm moist air moves over cooler air, usually bringing gradual temperature rise and light precipitation. Stationary fronts often happen when two air masses meet but neither advances, often causing prolonged cloudy weather. Occluded fronts. Occluded fronts form when cold air front overtakes warm front, producing complex weather patterns and precipitation. Types of weather fronts. Cold fronts and effects and features. Rapid temperature drop. Cold fronts bring sudden and significant drops in temperature as cold air replaces warm air quickly. Intense weather events. Strong uplift of warm moisture causes thunderstorms and heavy rain along that cold front. Wind and pressure changes. Cold fronts cause sharp shifts in wind direction and drop in atmospheric pressure. Warm fronts, features and effects. Temperature changes. Warm front causes gradual increase in temperature as warm air replaces cooler air ahead of the front. Precipitation pattern. Warm air fronts produce prolonged drizzle or light rain due to gentle ascent of warm air over cooler air. Cloud formation. Warm fronts are associated with widespread saturation for clouds forming ahead of the front, leading to steady precipitation. Stationary and occluded front characteristics. Stationary front features. Stationary fronts stay nearly fixed, causing extended periods of cloudy and wet weather conditions. Occluded front dynamics. Occluded fronts merge on cold and warm fronts, leading to heavy rains and rapid temperature shifts. Weather changes associated with the fronts. Precipitation and storm patterns. Role of fronts in weather. Fronts trigger precipitation and storms by forcing moist air to rise, initiating cloud formation and rainfall. Cold front storms. Cold fronts produce intense short-lived storms characterized by rapid weather changes and heavy rain or thunderstorms. Warm front precipitation. Warm fronts cause steady, widespread rain, often lasting longer and covering large areas of cold front storms. Geographic influence on rainfall. Local geography enhances precipitation though ongoing organic lift creates localized rainfall and storm patterns. Temperature shifts and wind changes. Temperature changes at fronts. Cold fronts bring rapid temperature drops, while warm fronts causes gradual warming in affected areas. Wind direction and speed shifts. Wind direction and speed change abruptly as fronts pass, influenced by air pressure and thermal gradients. Impacts on local weather. These shifts in temperature and wind affect local weather conditions and human comfort significantly. Impacts on local and regional climate. Frontal passages in climate. Repeated frontal passages influence seasonal rainfall and temperatures, shaping local and regional climate patterns. Mid-latitude climate dependence. Mid-latitude region depends on frontal systems for precipitation distribution to critical to their climate balance. Impact on agricultural and ecosystems. Frontal systems affect agricultural, water resources, and ecosystems by altering rainfall and temperature variability. Forecasting and identifying fronts. Reading weather maps and symbols. Cold fronts. Cold fronts on weather maps are represented by blue triangles pointing in the direction of the movement. Warm front symbols. Warm fronts are shown as red semicircles indicating advancing warm air mass. Stationary fronts are alternating blue triangles and red semicircles on opposite sides of the boundaries. Occluded fronts are combined purple triangles and semicircles on the same side to show complex of interactions. As you can see, the different types of the blue triangles is a cold front, the red semicircle is a warm front, the purple is an occluded front, and the stationary front is red and blue. Use of technology in tracking fronts. Doppler radar utilization. Doppler radar is used to monitor the movement of and intensity of weather fronts in precise real-time data. Satellite imagery. Satellite provides wide area views of fronts and helps track large-scale weather patterns from space. Computer modeling. Advanced computer models simulate frontal movements to predict hazardous weather for early warning systems. Enhance public safety. Technology advances enhance timely hazardous weather warnings, improving disaster preparedness and public safety. Significance for meteorologists and the public. Timely weather warnings. Accurate identification of weather fronts enable meteorologists to issue timely warnings, enhancing and public safety. Public decision making. Weather fronts information helps the public make information choices about travel, agricultural, and emergency preparations. Economic and frontal influences, activities, and health highlight the critical roles beyond science. The conclusion. Weather fronts shape our atmosphere and daily life. Roles of weather fronts. Weather fronts drive atmospheric changes affecting precipitation, temperature, and wind patterns worldwide. Importance of understanding fronts. Knowing how to identify and classify fronts is crucial for accurate weather forecasting and public safety. Adapting to weather impacts. Studying weather fronts allows better anticipation of weather impacts and improved strategies. Thank you very much for this quick weather presentation. This is Keith Capellaro from K-Dawg Weather. Please like and subscribe and hit the notification bell for more information. Thank you and have a good day.